So if we look at the compilation process, so typically within a compiler, this is probably the best way of actually demonstrating this. So on the left there, you can see the actual stage by stage. If I just look at the first bit, which is a preprocessor, and what it does, it takes the source code. This is the program you've written. And it then performs a task such as it merges files or anything that you need to include. And this is typical when we're actually running a compilation program. An example of that would be when I'm actually writing, say, a Python file or what have you, and you want to include something. So if I just demonstrate what that looks like to you. So let's look what the preprocess looks like when we're actually coding. So if we revert back to Thonny, because I think most of us are familiar with Thonny. So what we're saying here is typically the preprocess is the same as if we use our standard include, and if I just say include time, and just actually utilize the actual one. There we go. Right. So the preprocess will go off and it will go and find I'll say include. It's not include, it's import. I'm in the wrong language. Right, so import. There we go. Right, import time. So apologies there. This is the problem when you start switching between languages. You tend to overlap. On the C-based language, it's include. In Python, it's import. So import time. The preprocess will go away, find this library, find this function within the library, and actually run it. So hopefully, if I can just do this, clear shell, then run. There we go. You'll sleep and print out the actual output as we've said before. So the preprocessor is going away, finding out this function or this library within the function, and actually utilizing it. So that's the first part, the preprocess. The next thing we want to look at, and this is the area where students need to be familiar with, there are 4 stages here. Your lexical, syntax, and semantic, and what they've got the code generation and optimization is normally clumped together. So looking at that quickly, and I'm going to whiz through the next bit, you as students need to know what's incorporated in each one of those. All right? So if we look at the first stage, the lexical analysis, this is where we get our comments, spaces, and all these things are removed, and we've got our keywords replaced with identifiers. At this moment in time, you think, well, that makes no sense to me. Well, it talks about being split into tokens. What are these tokens? At this stage, if I just quickly go back to Thonny, so at the moment I've got my program here. So if I was coding, I'd probably leave a space between there. I've got my hashtag, my little comments to tell me what's happening. The lexical analysis, as we outlined, it gets rid of all the spaces, right? It gets rid of all my comments as such, because that's not needed. That's purely for my benefit, and it starts to split it into tokens. So I'm going to show you briefly what the token looks like. Now this example is purely for demo because this is an A-level question, so this is not going to come up in this format at GCSE. So here we've been asked to look at some code, and what we're going to do is to see how a program processes, and if I just look at that, this line, so within the actual line of code, this is just some pseudocode. How does it process that line when we start thinking in terms of breaking it down into tokens? So what happens systematically is we look at each of the actual reserved words, and you can see there we have certain reserved words, and then what will happen behind the scene, it allocates a token to it, and the token is just purely an hexadecimal number. So what we're saying is the print statement will have a token allocated to it as 2A, so every time it sees a print, it replaces it with that token, and the same for each of those individual reserved words, I should say, such as the equals, plus, comma, and open and close brackets. And that's simply it. So when we talk about these tokens, that's all what's happening. You just need to. I'm just giving you a more of a deeper understanding of how it works. Now, if I then have looked at the reserved words, we've got other bits that's left over, our variable names. Our variable name stroke user identifiers, each one of those in themselves, along with the data type, will be allocated an actual token. So these tokens, these identifiers, when you put them together, this is what it looks like. And then what happens then, behind the scene, it actually, in the lexical analysis, it actually goes through the code and replaces, and if I focus back on that single line we're focusing on, we say total. So if we look at total, well, total has a token of 7b. All right? The plus has a token of 2f. And num input, which is a variable, that has a token of 7a. So intrinsically, what that means is, when we convert that, we can see total is 7b, the plus sign is so we say total on the left hand side is equal to, we've got 2e, then we've got our syntax which we've actually added on there. So basically each one of those, 7b which is total, 2f which is equivalent to the plus, and 7a which is equivalent to the num input. And that's basically what that stage of the actual analysis does. If we look at the next stage, we'll just speed it on. Once we've got these tokens, we check them. They check them to see, are they grammatically correct? Have we used the correct syntax? If not, it generates an error. And this is done by passing each total. All right? So if we now look at a couple of key terms that I've used, parse string, what does that mean? Analysing each string. Syntax, this is the actual code that you're familiar with, and that's what you program with. If we look at the next stage, semantic, right, simply put, we need to check that the variables have been allocated and declared properly. Are we using the right type of variable type? Or if I'm holding an integer, and what have you, those are used for counters or whole numbers. If I'm trying to hold a decimal or real number, are those being allocated correctly? Each of these operators are checked to make sure they're valid, and providing that's the case, then it works its way through and gets through that stage. The last bit is a code generation. It's simple. In code generation, the machine code is generated. Similar to what I said before, that executable is generated, and that's it. The final stage, which is a subset of code generation and optimization, is within the optimizations process, we go through and we replace various things with a more efficient way of doing it. Because you may have a search routine which is being optimized, or any sort of feature that can be optimized, that gets replaced during that process. And the key thing there is, what are we doing? The objective is to do those three main things. Achieve the required output of the program, increase the speed of the program as it runs as efficiently as it can, and decrease the actual demand on resources, so we need less memory or having to read and write to external storage as such. So the final part of this video is just when we start to look at our programming errors. So the programming errors are pretty straightforward, and most of these you're familiar with. A syntax error. A syntax error, I've already demonstrated one of those already. So yet again, if you just look at our funny program, syntax error is nothing more than you've typed in a error. So when I come to run that, there it is. There's a syntax error. So you're all familiar with a syntax error. So let me clear that up. That's done. Edit clear shell. The next type of error is runtime and execution error. Right, so with a runtime error, this is an error that occurs typically at runtime. Easy way to demonstrate that is if I just open my funny file and ask a question. So here I'm asking you to enter your age. So when I run it, it should just prompt me for my age. and I'm 21 again, as always. No problem. Now, if I run it again, instead of entering my age, I type in some other input or data that's not expected. Type in Fred. It's expecting a number. I've typed in a string, and then that's your runtime error. So that's an example of a runtime time error. So if I just get rid of that, clear the shell. The next one is your standard logical error, and this can be in various shapes and form. This is where you could be, how can I say, just doing a simple command, and you're not thinking about the actual output. The program runs, but it's not correct. So yet again, if I go to Thonny, and here, if I can just say, let's just put a, right, I'm going to just put total. And this is just random stuff, by the way, ladies and gents. So total equals 0. And here, I'm going to say, if I just copy that, and instead of age, I'm going to say score. Score. Right, instead of making it 0, I'm going to say 10. And then I'm going to say score. No. Total plus score. Right. So, and here, right. So here, normally that's what you'd put, right? So I say total. The current total is 10. I've asked you to enter your score. I'm adding your score to the existing total. Then I'm printing it out. But if I, instead of putting the plus, I put that, and I ran it. Let's just do the age thing. All right. Enter your score. I had 22. You say your score is 1. So in essence, that's a logical error. The program has run. It's not generated an error, but I've got my logic wrong. The linking error, I think I've demonstrated that before. That is a simpler case of I've actually tried to import a library, and that I've not actually included it. So if I were to try and use this function here, so it's a link error. Either if I turn around and say import timex, it will complain that it can't find timex. Or alternatively, if I just clear shell, if I don't import it to tell it where to get it from, you just hashtag that out, and I'm trying to use one of the features from it, then that itself will also generate an error. So that's a linking error. It's trying to actually get the library and trying to link it. Either the library doesn't exist, or I've not told it where to get the library from, or I've not included it. So that's an example of a linking error. Oh, there we go. So now if I run that, that itself will run as always. It's just under 12, 22. So at least you know that works. The other final things you need to look at are rounding errors. So when we're doing some calculation or anything, or rounding up values, so rounding errors typically where the answer it comes out as a decimal. So we've got an answer which is in the region of 34.5, and then what we've done, we've rounded it up to 35, so we've got an error of 0.5. On the flip side, truncation, this is where we do the same, and we might have a number which is 34.9. So if you look at it, it's 34.9, and then what we've done, we've rounded it down, and straight away, within our calculation, we've got an error of minus 0.9. So these are examples. make sure you take the time to actually work through it and actually understand how it works. It's important that you practice it. And to finish off, if I just show you, and this is where I need you to actually take some time and actually pause the video. So what does it look like? These are typical questions. So at this point, if you pause the video and then go back and try and have a go at it, I will now show you the answer. So these are typical questions. Compilers, interpreters translate high-level languages into machine code. Describe the main differences between them. And that's a typical question. So pause the video, have a go, and once you're ready, play the next part of the video and you'll see the answer. So here's the answer. Take your time to go through it to see where the examiner would award marks. As I say, the question is in two parts. Now if I show you another question, it's again, pause the video and take time to actually visualize how you can answer this question. Now, having paused the video, here's the answers. So you can see yet again whether the answers are true or false. Make sure you're familiar with it, because these are the typical type of questions that you'll come across, and that more or less completes the recap of program constructions.